Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Chaos Borders by Vizumation, and here are the rules. Irregular Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and region. There are 9 regions in the grid that must be located by the solver, and every region is a 9 by 9 space. This is actually more chaos construction rules. Actually, this is more just basically chaos construction rules, because chaos construction rules is essentially irregular Sudoku rules, but you create the regions. And every regions, so there are 9 regions in the grid that must be located by the solver. It doesn't say, but basically all the regions have to be orthogonally connected in whole, which means that basically, for example, this could be a region, because as long as you can go from any cell in the region to any other cell in the region just by staying in the region by going through edges, right? So you can go here, 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 to here, 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 to here. These could also work. This would not work as a region because, again, you can't go through this cell to any other cell in the region to every other cell. It has to be able to go through to every other cell in the region through edges and still stay in the region. I wish there was a better way of putting this that would be easy to grok, but I'm not sure if there is. Anyways, that's chaos construction rules. We have also a digit in a cell with arrows counts the total number of region borders seen in the direction pointed to. The outlines of the grid do not count. So basically, say we had a region here, a region here, a region here, and a region here. Actually, we had, well, we can't have that. And then we had a separate region here. Since these are all different regions, this would be a region border, so this counts as 1. This is a region border, so that counts as 2. Actually, let's make this then another region. So this would count as a region, so that acts as 1. These is a region border, that's because these 2 regions have a border, that's 2. These regions have a border, that's 3. So the region borders here would be 1, 2, 3, 4, and 5. So in this instance, this would be a 5, and this would be a 4. Because this, again, sees 1, 2, 3, 4 region borders. And remember, the edge of the grid does not count. Or the outline of the grid does not count. And this would see 5, because it would see a different one. The cells with 2 arrows adds up the count from both directions. So this would count the region borders it sees going this way, and it sees going that way. And region borders separate lines into segments with the same sum. So these are region sum lines, essentially. So say we had this region here, something along the lines of this. Then, how do we say that? Well, let's just say the regions were like something along the lines of this, and this was the same region. This doesn't really work for this doesn't quite work for essentially building a region, but let's just say that this region sum line here was essentially something like this, right? That would mean the sum of these 3 digits must be the sum of these 2 digits, which is the same as the sum of these 2 digits, which is the same as the sum of these 3 digits. Because region borders separate this line into segments, so this is not the same segment as this. Therefore, these 3 would have to equal the same digit sum as these two, which would equal the same sum as these three, which would equal the same sum as these two digits here. So that's how region sum lines work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. This has at least one region border here, and maybe two. Same with this. This is 1 or 2, and this is 1 or 2. That's interesting. That would mean this has to be the same region, right? For this, well, you could have one here, and this is a full region by itself. What you do know is that this cannot have a region border here. So one of these is 1, and one of these is 2. That means this can see, how many can this see? It sees 1, possibly 2, 3, 4, 5, 6. So this could be up to 6. This is 3 through 6. This sees at most 1, 2, 3, 4. So this is 1 through 4, and this must see 1 more than this. So we know this is a boundary here. I guess we'll mark this medium and dark here. This must see 2 through 5. This sees 1 through 5 here. This sees 1 through 4 here, right? 1, 2, 3, 4. This sees 1 or 2 here. This sees 1 through 3. Cannot be 3. If it's 3, that means each of these is the same. You would have to have a region border here, here, and here to have 3. And therefore, all 3 of these would be basically the same digit, which is not allowed. So this is 1 or 2 here. This sees then 1 or 2 in this direction here. This could be 3, 4, 5, 6, 7. So this is 2 through 7 here, because it has to include these amount here, and potentially be higher. This sees 1, 2, 3, 4, 5, 6, 7, 8, possibly borders here. So this is 8 up to 8. This sees 1 or 2, 3, 4, 5, 6, up to 6, right? 1, 2, 3, 4, 5, 6. Yeah. And it has to be greater than this digit, so this is 2 through 6. This sees 1, 2, or 3 for the same reasoning. This sees 1, 2, or 3. And this sees up to 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. What do we have? Okay, can this be 1 and this be 2? Well, we know this is a 1-2 pair, so this is 3 through 9 here. These have to be the same region. If these are different regions, then you cannot have 1 and 1 adding up to 2. So these have to be the same region. We know that for certain. One of these is 2. What other regions possible? So can it be region here and this be 1? I don't think so, right? This would have to be 2. And the problem is, well, I guess it could be. That does actually kind of work. Can it be 1 here and then 2 here? I don't think that's possible, right? So this would be the same region here. This would have to be a separate region. Let's fill in the entire outline of the grid. So say we tried to have something like that. This would be 2. I guess that would be possible. Something like that. This would have to go here then. So this would have to go out this way. That would go that way if that's the case. This would be 1 then. That would see 1 boundary. This would be 1. This would be 2 because it would see 1 and 2 boundaries. Neither of these could be 1. This can't be 2. This sees 1, 2, 3, 4 boundaries here. This has to continue out. So this one would form essentially its own boundary. It would have to go here. This has to extend out. This extends. Actually, we don't know if that's a boundary here. We don't know if this is a boundary. We do know this extends out here. This would have to extend out that way. This would extend out here. This would be green, obviously. This would see 1, and this would be 2. That's possible. This would see 1 boundary, so these could not be 1. This would be 1, this would be 2, so this couldn't be 2. This would see at least 1, 2, 3 boundaries, and maybe 4. So this would be 3 or 4. This would be a boundary here. This pink would have to extend down here. The green has to go out, and the pink has to go out. So the green has to be one of these. Hmm. This cannot be 2. This misses a boundary here. So this cannot be 1, it cannot be 8. The rest of this is 3 through 9. And 3 through 9 here. This is 6. 7, 8, 9. Where can the light go to, essentially? This cannot be pink. This has to be either green or some other color. This could be green, pink, or some other color. Light cannot go this way. We have 6 lights already. This could be light here to here, potentially to here. 1, 2, 3. Actually, cannot go that way. It can't go all the way here because it needs access to a 1 and a 2. And 1 and 2 are accounted. 1 is accounted for already all the way here. So it cannot be 1, 2, 3 here. So it could go 1, 2, 3 or 1, 2, 3. These are potential lights. This could be medium dark, medium dark. This could be dark. These could be all medium. So far, this seems okay. Technically. This could be pink, obviously, here. Pink could go any of these ways. Hmm. Yeah, this one doesn't. Okay, so I did a chaos construction rule a little while ago, and there it said region border separates each line into segments. This does not. So we cannot necessarily have the assumption that the region sum lines are going to be split by region border. Hmm. Huh. This is at most 2 here, right? You could have 1, 2 here. This would be 3, 4, 5, 6, 7. Okay, yeah, 7's still there. Huh, interesting. Okay. What other things can we try to rule out? This doesn't seem to go anywhere. This seems actually potentially valid, assuming that region borders aren't necessarily restricted there. What happens if this is 2? If this is 2, we have a boundary here and a boundary here. This then cannot be 2 here, because then this would be a box by itself. So this has to be 1, this is 2, which means we have a boundary here and a boundary here, and that's problematic too. So we know then this can't be 2, this has to be 1. So this cannot be 1, this cannot be 1. if we have 1 here, say this is 2 here, then we have 2 and 2. One of these is 1. It would have to be there, then, if that's the case. What if we had 2 here? If we had 2 here, that would be a boundary, that would be a boundary. This would obviously go there. This would have to be a separate one. And we have a contradiction here. Okay. So we tried to, okay. First of all, we tried this to have 2. So if this was 2 borders here, the problem is one of these is 2. So if this were 2, this would then have to be boundary here, and that would form a region, a cell which doesn't have a region. Same here. If this were 2, that would be boundary here, and that would form a cell without a region. So this can never be 2. This is a 1 here. If this were 2, we would have to have boundary here. This would be 1 then. This would have to be a boundary here. This would have to go this way. And the problem, okay, so this would be 1. This would have to be boundary here. That means pink would have to go this way, but then this boundary 2 would not work. So this can never be boundary 2. This has to be boundary 1, which makes this boundary 2. So we know this always has a boundary here and here. So we know this for certain. Yeah, we tried this. That seems to work okay. What about this? What happens if we have this? Then can this ever be a boundary? If this is a boundary, the problem is this doesn't work, right? Okay, so if we have a boundary here, you could have boundary there, right? And that works. If you have boundary here, this cannot be a bound. Okay. Can it have boundary here and then boundary here? No. Right? Because this would have to be a separate boundary here, but we know this can never add up to any reasonable suggestion, right? It can't have 1 and 1 adding up to 2. So this has to be the same boundary, same region, but then this boundary wouldn't exist. So that's a contradiction. So if you have a boundary here, this can never be a boundary. If you have a boundary here, I don't think this can ever be a boundary, right? If this is a boundary, this, again, has to go out somewhere, but this boundary, this means this has to be part of the same region, which would never have a boundary here. So, either way, this has to be a boundary here. So this must extend out this way, no matter what. One of these is a boundary, so it either goes here to here or here to here, right? So it's either 3 here, and this is a boundary here, or these are all the same. Either way, it could be this, so either it's all this, or it's all this. So either way, this has to be 1, because this region, again, this has to be separate, 2 separate regions here. So either this is a region here, and this is part of green, or this is a region, and this is green, right? We don't know. Either way, this has to go out. It cannot be part of this region, so it has to always go out this way. So this is actually guaranteed. So this is always 1. This can't be 1. This can't be 1. This has to be a separate region, so this is 2. So it needs a region boundary here. This has to be a region boundary here. That means the pink has to go out here. So this is guaranteed, actually. We know that these have to be separate regions. This has to go out this way. Guaranteed. So this is actually still guaranteed. So this is actually accurate. It has to go this way, then, in some sense. Right. This sees 1, 2, 3, at least, and it could be up to 4. This could be 2 through 4 this way. We know pink does have to go out this way. Green has to go out somewhere here. So this is green or some red here. This could be green, red, or pink. Or technically another color, yellow. No, because either green goes out this way and this is red in some sort. And this is pink, no matter what. This, again, must be 3 through 9. This is 3 through 9 also. This is 2 through 9. This can't be 1. This sees at least, so this is at most 7 regions, because it cannot see 8, because one of these region boundaries is gone. This needs access to a 1. Say this was a 1 here. We would know then this is pink. So light would have to go this way. Right? Because this cannot be... If we just... Well, no, that's not technically right. You could actually... No, this can't be all pink. We know green has to exit out. So this does have to be pink, right? Ah, and that's a contradiction. So this can never be 1. Okay, so the reasoning here, say this was 1. We know the green has to escape out this way. So the green has to be here. We have a pink here somewhere. So the border has to be between the green and the pink somewhere. Therefore, this must be pink, but we have 2 ones in the pink region. So this cannot be 1. This has to be 2. Pink goes this way, it cannot be boundary here, because then all 3 of these digits would have to be the same sum, same digit, because they add up to the same sum. So this must be a boundary here, and then it must be a boundary with green. So this can never be red. So one of these digits is essentially the boundary. So this has to be a separate region. This 2 means this can't be 2. This can't be 2. This has to be 3 through 9 here. This is a separate region. It could be light. So this can't be 2. This already sees 1, 2. You could just have 1 here or 1 anywhere here. This can't be 2 here. This light needs access to a 1. Could be 1, 2, 3, 4, 5, 6, 7, 8, 9. So either of these could be 1. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. And this would be 1. But, okay. If we tried to go 1, 2, 3, 4, 5... Okay, so if we tried this light to have 1, 2, 3, 4, 5, 6, 7, 8, 9... The problem... Actually, one problem is it can't have a 2 either. And this would be 1. And then this would have to be a separate region than these 2, at least. So it would have to be 1 and 1 and 1. And 2 digits cannot ever add to 1. If this were a separate region and this is a separate region from this would have to be a 1, and you'd have 2 ones in the same column, which is not allowed. So this light can never go this way. This light does have to go down here, and it must connect to a 1 somewhere. So the 1 has to be one of these ones here, because there's just no ability to get to another 1, right? We tried reaching this space, and that doesn't work. I guess it could go 1, 2, 3, 4, 5, 6, 7, 8, 9. But the problem is then this becomes 1 by itself. You can't have a 1 here because of the 1 in the column. This 1 eliminates 1 going this way. So that would mean, yeah, if we tried going this way, this would be its own separate region because of the light region, and that must be a 1. If you can't have 2 digits adding up to a 1, and if you had these 2 separate regions, you would have a 1 here and a 1 here, which is a 1 in the same column. 2 1s in the same column. So that does not work. So one of these is a 1 here, which makes this a 3. Therefore, we have 3 region boundaries here. That's interesting. This has to be the same region here, because if this were a separate region, you would have a 3 and a 3 here, which is not allowed. So we're going to color that yellow. Light cannot get to here. So one of these has to be like red. One of these is 1, so this is at least 4. So it's 4, 5, 6, which means this is 7, 8, or 9 here. One of these... We don't know if these are separate regions, really. This cannot be green. If this were green... If this were green, that would force this to be green, right? It can't go here because this is a separate region. If we try to go out this way, that doesn't really work, right? And it would still block everything else here. So if this is green, it would have to go here. And even if you try to connect that way, this would be essentially another region. If we try to go here green, the problem is all of these would be green, therefore there's no boundary here, and therefore this cannot be 1. Sorry, this would have to be 1, because it would only see this boundary here, which is not allowed. So this has to be red or pink, likely red though. Because if pink, yeah, I don't think you have to have some access to. Okay, it cannot be pink. If it were pink, the problem there would be then essentially, how does this work, right? Oh, this can't be 3 either because this is 3. How would this work? You have pink go out this way. This green region then is at most 7, which is not allowed. So this cannot be pink. This has to be a red. A separate region. You could extend here. Okay. Say these regions were not... Well, I guess you could have red here. That is possible. So this could be red and red. Can this be pink? If this is pink, it cannot go any other way here, so this has to be pink. This would be at most pink. That would be 1, 2. Okay, so how many greens possible then? 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 1, 2, 3, 4, 5, 6, 7, 8 possibly green. And that's not possible. So this cannot be pink either. Therefore, this must be green. It must go out this way. So... How many region borders can this see? Pink can never get here. Red, this green has to somehow get to here somewhere. And then it will block off any other region. So this has to be 2 then. So this is 2 no matter what. The red cannot go here, and it will block off the green from connecting to itself. So this could be red or green. This cannot be red, but it could be green or pink. This is at most 1, 2, 3, 4, 5, 6. So it would have to be 7, 8 at least. These are both pink then. These are guaranteed pink. So this is not, or this is a border here. This is a border here. You could potentially go out here. You could potentially go out this way. We're not sure. This is either pink or red. We're not sure which one that is. 2, 3, 4, 5, 6, 7, 8, 9. So this doesn't have to be pink here. This could be pink, light, or yellow, or some other region. This is 3, which means none of these can be 3. So this is at least 8 here. So pink, light can go any of these 3 spaces. It could go here, and this could be green as a possibility. So this is the extent that light can go to. Obviously, this could be medium. Dark cannot get here. But this could be medium or dark. Medium or dark here. Okay. Can this ever be yellow? I don't think so, right? If this is yellow, well, pink could go out this way. Green can obviously not go here. If green goes here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, well, it can't even go that way. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 already, potentially. Either way, it has to get to 8 here. This cannot be green, but this could be green or red. This red has to go out this way because there's no other, like, it has to extend out this way. Technically, it could be red here. Okay, 1, 2, 3, 4, 5, 6, 7. No, so this has to be red here. So this is 7 reds at most here. 8, this has to be 9. So these are all red guaranteed. Technically, pink could go here. Green cannot go here because we have to get to this place here, you have to have 8 in the region. So 1, 2, 3. Actually, that's not true. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. You could actually have it green here. You could have this yellow too. That's actually possible too. Okay. This red needs access to a 1. 1 can't be here. 1, 2, 3, 4, 5, 6, 7, 8, 9. This cannot be pink because if it's 1, 2, 3, 4, 5, 6, 7, 8, 9, red is only 7 in size at most. So this could be red, it cannot be green, it could be yellow. It could be some other blue, but it just can't be pink, it can't be green. You could extend pink out here. 1, 2, 3, 4, 5, 6, 7, 8, 9, actually. That doesn't work though. If you have 1, 2, 3, 4, 5, 6, 7, 8, 9, the problem is this would be the same as that digit because this would be the only, this would be the region border, this would be a segment, this would be a segment, this would be a segment, so this can never be pink. The dark can never go here because of, so this could be light, medium. Actually, it can't be light. It can be only medium here. It cannot be dark. It could be yellow, though. Or some orange. Right. This could be some orange here, too. We're not certain. We do know this is all light. The pink needs a 2. Where is the pink 2? Cannot be here, cannot be any of these, cannot be here. So the pink 2 could be either here or potentially here. Okay, pink can get up to here. That's potentially possible. Could be medium, dark, or orange of some sort. This sees the border between light and pink, and it must see a border between pink and green. So this is at least 2. So it cannot, it's 3 through 8 still. Okay. So the 2 could be either here or here for the pink. We're not sure where. The red needs access to a 1. None of these can be 1. This can't be 1. This can't be 1. So the red 1, actually the 1 in column 2, where is it? It has to be one of these 2 cells. Okay. This has to be 3 through 9, but this can't be 3 here. Hmm. 'Hmm. The medium needs access to a 2 also. This is 3 through 9. 3 through 9 here. This is 2 through 9. And if it's another region, this is 3. This can't be 1, 2, or 3, so this is 4 through 9. One, 2, 3, 4, 5, 6, 7, 8, 9. So it's possible this is all dark. This can't be 2 because of the 2 here, and it cannot be 1 because the pink has a 1 and the green has a 1, and this can only be pink or green. So this is 3 through 9. Actually, it has to be the central one. So this is with either pink to add up to the digit in the green region, or it's with the green, which adds up to the pink digit. So it can be at most 6. This is 3 through 6. Therefore, this would be 7, 8, or 9 here. This would be 7, 8, or 9. This... Oh, that's interesting. If this were dark, how would this work? We know this is... Wow, that's a lot. 1, 2, 4, 5, 6, which is 18. So this region sum must add up to at least 18. So you can never have 2 digits here which are the same. Okay. This is interesting. This is a segment by itself because the light needed access to a 1, and this was the only access to 1 it could get. Therefore, this would be 5 in size at least. It cannot have 3. It has to have 1, 2, 4, 5, and 6 at minimum. So that means that adds up to 18. You can never then have 2 digits in a region which would ever add up to 18. So this all has to be the same region, period. Because if you try to have only these 3 be part of the same region, obviously, okay, so you can't have these 2 by itself be the same region. If these 2 are by itself the same region, the most they can add up to is 17. The minimum this can add up to is 18. So this is 17 at most if this is 2. It cannot be just 2 by itself. If we tried 3 here, either this is part of the light region, which would then be 6, so that would be 21, and then this would have to be its own separate region. and that would be a single digit, which would add up to try to add up to greater than, which would add up to greater than 21 or greater, which is obviously not possible. Or this is a two-cell region, which again, you cannot add up to 18, which is the minimum for this five-cell region here. Therefore, these four are the same region, period. No matter what it is. It cannot, it could be 6 here and then 4 digits here adding up to the same. Or it could be 5 of these digits adding up to the same, and then this would be light if that were the case. So this can never be, this could be light, it could be orange, a different region, or it could be the medium. So this can never be dark. If this, well, this could be dark. And then this could be light. Okay, so that's possible, I guess. Okay. So this could be orange, could be dark, it could be medium. And it has to be, so this is essentially a region in itself. So there are no borders here. There is one in one of these. So you have one here, but you can only have one, right? This is either all the same here, and this is light, or this is light, and this is all the same. So this would have one border here, which means you need two other borders. So it has to be here and here, right? So you have only one border here, because this has to be the same region. This could be light, with this being the same region, or this could be all the same region here. Either way, there's only one border here. This must have border then here to make this 3. So this is 3. This cannot be 3. There's no 3 in the column then. This could be 3. So if this is pink and pink, it's 4, 5, and this is 9. If this is green and green, it could be 3 through 6 added together to add up to 7 through 8 or 9. So this cannot be 7, 8, or 9 here. Sorry, this could be 9. This is either 9 or it's 3, 4, 5, 6. This is 3, so none of these can be 3 here. Let's see. So this is bounded here. Obviously, I guess this could be orange too. Yellow could technically go here. Yellow could go here too. Yellow cannot go to here because then it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So yellow could get to here. Light could go here. Where else can we go? Can this ever be 4? If this were 4, this would be 3. So you'd have a border here to 3, which means this is not a border. So then you'd have at most 1, 2, 3 borders here, which is not possible. So this can never be 4 in size. This is 2 or 3. Oh, this can never be pink. Actually, pink could go here technically. So it could be pink, pink, pink. Okay. We have, again, 6 pinks here. It could go pink, pink, pink here. And then this would be a separate region. Obviously, it could be yellow. It could be some orange. It could be even medium. It cannot be dark because, again, that would block this off. The medium. I guess this could actually be medium too. Right? It could go extend that way. Huh. Let's see. Okay. What happens if this is 3? That is actually interesting, right? So it has to go this way. This all becomes medium, right? Because it extends to here. This is a boundary. Um, we have one boundary here. You could have 2, 3, 4. Okay, where the boundary could not be here because this would require 2 digits adding at least adding up to 4, and 1 and 3 are already taken. So the boundaries then would have to be here and here. So this could be 2 here. So this would not be medium. This would be dark. This would have to be dark. It has to extend out this way, so this is all dark. This would be 4 digits adding up to another digit, which is not possible. So this would not work. So this can never be 3. This has to be 2, which means this cannot be 2, so the 2 does have to be one of these two no matter what. Actually, yeah, can this ever be 4 is the question, right? This would then be dark. You have block here. This has to be then all medium gray. I guess, obviously this would have to continue here. You have one here, and you could have one here, right? What you cannot have is one here, because then this forces the dark to be there. So then this would all have to be dark. This would be a region border here. You can only go... This would have to be dark because this is not part of the dark region. It would be 1, 2, 3, 4, 5, 6, 7 at most, so it has to exit out. This would be 8 at most, so it has to go there. This would have to exit out somewhere. So this would be like orange, I guess. Obviously, this could not be dark anymore. This couldn't be the orange that I want here. Either both of these would have to be the same region no matter what. So 1, 2, 3, 4, 5, 6. This could not be 2 or 4 here. Oh, wait, this can never be... Well, okay, we know this is 2. But this could never have been 2 anyways. Either it's a separate region, which means this would have to be 3 to add up with 1 and 2. Or it's green, which means it could not be 2 either. This always has to be the same region as this. So there's no border here. Because if this is 3 and it's separated out, that means these 2 digits at least. Plus, you can't have separate region here and here. And you have 2 digits adding up to 3 without a 1 or 2 possible, which is not possible. So 4 is also the same problem. So this has to be the same dark or medium region. Heck, this actually doesn't even have to be. It could be like some sort of orange too. It doesn't actually have to be dark. This can't be 2. So can this ever be all gray? I mean, you could do something like this is light, and then this is, well... If this gray, medium gray, extends to here, it will always include these other 4. So that's 7 at least. So you can have at most 2 other grays. So it could be 1, 2, it could be 1, 2, 1, 2, 1, 2, but these cannot be gray. Right? If you tried to go here, this becomes part of that medium gray. Because you can't have just 1 digit by itself there. You could have something like this. That's possible. So the medium gray goes either here or it goes this way, and this is some other color, other region. You could have dark go this way, and then... No, you cannot have dark be here. If dark is here, being this medium must cross this line. So this can never be dark. So dark can never cross this line here. Because again, it has to be part of either the medium gray or some other region. If it's dark, the medium gray goes here, and then it has to be medium gray here. And that blocks up the dark. So dark has to be one of these 2 regions here. Okay. That's pretty clever. Let's see. Actually, we know this can't be... This is 4, 5, or 6 here. So this can't be 1, 2, 4, 5, 6. It could be at minimum 1, 2, 4, 5, 7, which is 19, which is even greater. These 4 are in the same region. Okay, okay, so say we try to have gray go all the way here. I don't think that's possible. So if gray goes all the way here, there's only one boundary here. So this can never be gray here. This is either dark or some orange or some blue, right? This is dark orange or blue. This so this is all the same region here. This could technically be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this would be a separate region. So this does not have to be a separate region as this. This could also be 1 through 9, and then this could be there. So that's not anything, any information, extra information there. This dark could go out this way, so this doesn't have to be dark. Yeah, I'm guessing this is likely 3, but we're not guaranteed that. This can't be 2. Oops. Oh, these digits are all 3 through 9. But this can't be 3. 3 through 9 here. This has at least 3 boundaries. These two are the same region. Where is the medium gray have to go? Can this medium gray ever exit out? It cannot. Right? So we say we try to have this medium gray exit out again. That means this would be essentially only one boundary here, and that's not possible because we know we see 2 region boundaries here. Therefore, this medium gray must extend into here. So we know, so it has to, if it tries to go this way, the dark region can never be 9 in size. So this is always medium gray. We know that for certain, and it either connects this way or it connects this way. We're not sure which. So this can't be some orange. It's either medium or it's gray. Therefore, this is 3 through 9 also, because we have a 1 and a 2 already in the medium gray region. So it could see... Okay. The dark could be all here. That's possible. Still. No. The dark cannot be all here. If the dark is all here, there's only one boundary here. So the dark cannot extend all the way here. This, whatever region this is, has to extend down here then. Same with this one. This has to extend down here. Because this cannot be all dark. We have to have some sort of... We have a region border between medium and whatever's here. And then we must have another one here. Okay, where can the region border here? Can it be here, is the question. Maybe? Huh. We have the gray in the next area here. Is the point. This has to extend down here. This has to extend down here. Because you can't have all of this be the same region. right? Which would force this, allow this to happen. This can't be all the same region, which would force this to happen, possibly be the same region. So this has to extend here. This has to extend here, guaranteed. Now you don't. Okay, so say you had something like that. That is possible, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is a separate region because this would have two regions here. Let's not make it blue, I guess. Well, let's make this not orange then. Let's make that blue, potentially. One of these is orange or dark, the other one has to be orange or dark, right? This could cut off here, so that's fine. This could actually, it cannot extend to it. Well, it could, as long as this is a separate region. That's fine. Okay, so medium gray cannot go here. This has to be dark. If this is, well, dark could actually go here. Dang it. It cannot be medium. That's all we know. This is orange or dark. This is orange or dark. These are orange or dark, but this could be medium. Right? 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9 is possible. Then dark goes here, and then orange goes here, and that's possible. Or yeah, this is its own separate region. Hmm. So we have 1, 2, 3, 4, 5, 6, and one of these is 7. Could be both. Gray could go over to here, and it obviously could be orange or dark also. This is orange or dark. It cannot be gray because that would block both of these regions, which is not possible. Gray could go over to here, and that's the extent, right? It has 7 at least here. It could go 8, 9, or 8, 9 here, 8, 9. And that's it. These could be orange, dark, or blue. Right. We know this is gray, period, though. Because of these borders, we know there's 2 here. This has to be at least 2 here, so this is at least 4. And, well, we don't know. It could be gray, technically. Huh. This could be yellow. So yellow could extend to any of these too, technically. Actually, yeah, it could go to here too. Red is 4. It could be 5, 6, 7, 8, and 9. So that's technically the range of red. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Oh, this can't be red here. So red could go to here. Obviously, yellow could be any of these. Dark cannot. Okay, where can dark go to? 1, 2, 3, 4, 5, 6, 7, 8, 9. So dark cannot go there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So dark cannot go here. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So dark cannot go here. 6, 7, 8, 9. Yeah. Red can extend to these two. Red technically can go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So red is only at most here. Red could go here, actually. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the extent of red. Pink could go to here. Orange technically probably could go up to here, or here, or blue, I guess. It's kind of, yeah, in the, kind of broad. This could be orange. This cannot be dark. Red cannot be here. Pink cannot be here. Light cannot be here. This, we don't know about this one. Even if this is gray and this is gray, actually it couldn't be both grays. 1, 2, 3, 4, 5, 6, 7, 8, and 9. You could do that, but these both cannot be gray. Even if this is gray and this is light, say, that would be one boundary, two boundaries at least. You'd have three boundaries between here, and then gray cannot extend here, so this is at least four also. This cannot be three. Okay. Yellow needs a 1, and it cannot access it here. Or here. Obviously, this is the red one. So where is the yellow one? It has to be one of these, which is pretty broad. One of these, even one of these. Yeah. Orange and dark both need 1. Aha. Dark can only extend to here. Bingo. Okay. Where can dark extend to? It can only extend to here. I guess it could go down here. So one of these has to be a 1. We don't have necessarily an orange requirement. We do know there has to be, orange has to be at least one of these two cells. That's all we know. If medium went to here, that means dark would only go, I guess one could be here also. That's not a requirement then. One could go here. Okay, never mind. That's not a requirement. That's not very helpful. Never mind. Because one could be here, right? And so the dark could actually extend to here. We would have to have another one, but the orange could go in many places. Let's say this was a 3 here. That would make this medium, right? Because these would have to be one. You would already have border, border, border. This would not be 3. So this could not add up to this. This would have to be green. This would be 3. This would also have to be medium. But could it be all 3? Maybe. Hmm. Huh. Yeah, that seems feasible. Wait, hold up. No. This is medium. There's no boundaries here. That would force this to be boundary, boundary. Right, so this can... Okay. This can never be medium. If this were medium here, that would mean you'd have to have medium... I guess... No. Because again, this would... You can't have 2 digits adding up to this digit here. If this is 3 or 4, because this would require 1 here, no matter what, if that's the case. So this cannot be medium. This is orange or dark. This could go out that way. If this is all the same, no, region. So say this was orange. If this was orange, I guess you could go all the way there, and then this would be all dark. That's possible. Hmm. If it's gray, this could be essentially its own region. This would be its own region here, and this would be connected this way. I'm guessing my question is, can this ever not be a boundary here, right? So these are the same region. You need a different region here. So if this were, say, it cannot be both darks, because then there would be no other region allowed in this area, because it'd be dark or medium, and that's it. If this is both orange, dark doesn't have enough spaces to form. So this must be essentially a boundary. And since this is a boundary, I get you could have gray. This could be the same region. This could be a separate region. That's possible. Maybe we should color things from these perspectives instead of this one. Okay. So this, I guess we're gonna make orange, and this will make dark. So this could be orange or dark technically. Oh. This... You can't have 4 oranges here. You can't have a gray with an orange there. So say you had 4 oranges here. That doesn't work. So orange cannot actually get to here according to this restriction. This can't be orange. You just can't reach there. If we tried to have orange go all the way around here, so we tried that is orange. There's no boundary here, so these two are the same. Therefore, orange would have to reach all the way around if that were the case. So this cannot be double orange then. This is either dark or it's medium. This is 3. It could be extend 4, 5, 6, 7, 8, 9. So these could all be dark, technically. Orange can go to 1, 2, 3, 4, 5, 6, 7. Can't block off the dark. 1, 2, 3, 4. It cannot. Well, could go this way. Hmm. 9. It cannot block all the way here. Technically, it could go up here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, actually. So this could extend to here. Could extend to there, technically. It cannot go here, I don't think. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, because if it tried to do that, this would both be medium gray. And you'd have access to you'd have 3 cells, one which could be light, one which could be medium, because we have 1, 2, 3, 4, 5, 6, 7, 8 medium, and then one which could not be anything else. So this cannot be this can't be dark gray, because that would cut off access to anything else. Let's remove the blues. The blues are not helpful right now. We know yellow's here. Blues could be any of these, technically, right? We just want to know where the edges of the dark gray and the oranges are. So technically, you could have 1, 2, 3, 4, 5, 6, 7, 8, 9 darks, and therefore orange could go here. 1, 2, 3, 4, 5, 6, 7, 8. So this could be orange also to here, 9. And it cannot go here because it would block off that. Actually, maybe it could. 1, 2, 3, 4, 5, 6, 7, 8, 9. You'd have 4 cells. 6, 8, 9. You'd have 4 cells here, one of which could be light, two of which could be medium, but then the other cells would be blocked off. So orange cannot go here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it could go down to here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it could go down to here too for the orange. What else? Hmm. I'm gonna pause because I need to go to the bathroom right now. I'll be right back. Okay, and I'm back from the bathroom. Let's continue on. Let's see. Hmm. Hmm. It's two. Can this ever be 7? Well, we have 1, 2 here. This could be not light. I guess this could be medium, and this could be like yellow, right? So then medium, yellow, medium. So that's 2 there, 3, 4. This would be 5, 6, 7. So 7 is actually possible there. Can this ever be 8? Red, green, pink, light. It could be dark, dark, medium, dark with orange there. Oh wait, this is 1, 2, 3, 4, 5, 6, 7 at most. So this has to be orange here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 8. Right, because it can't be 2 oranges here, right? Because that'd be 4 orange digits, which add up to 1 single digit, which is not allowed. If we tried to have 3 here, the problem is this would be a single by itself. So therefore this couldn't be orange. These two have to be the same no matter what. Hmm. I'm pretty sure my guess is this is light. It's not green. If it's green, it could be anything, really. So, um, can this all be the same region? Technically, yes. Hmm. Can this be 7 regions? No, yeah, or 7 boundaries, possibly. This could be 3 boundaries. This is a separate boundary than this, which is a separate boundary than this. Could be essentially like dark here, orange all the way here. Um, some yellow or blue. You have blue here, or something going up here, and then this would extend to there. Maybe it's like that. That's possible. This is at least, at most 30. So this could very well be here. Hmm. It could be 1, 4, 5, 6, 7. So 4, 5, 6, 7 would be 22. Plus 1 and 2 would be 25. And that could add up with 4 digits. That would be fine. If these are both gray, this could be single. I have 1 here. So, okay, if this is 3, these are both Not dark, they're medium. 1, 2, 3, 4, 5, 6, 7, 8. This would not be 3, so this would have to be green. Hmm. Hmm. We have 1, 2, whoops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible air cells for green. Okay, these are 3 through 9. 3 through 9 here, 3 through 9 here. This is also 3 through 9. This can never be 6. If this were 6, it would have to add up with a pink, and a pink would be 4 at least. So that would be 10. Or it would have to be the sum of the two greens, which is not possible. So this cannot be 6 here. That doesn't really tell us much. Hmm. These are 3 through 9. One can be here, potentially here, or here. These have to be different. So 1, 3, 4 through 9. This could be 1 or 2 here. This could be the full line here. These are 1, 4, 5, 6, 7, 8, 9. Okay. Oh, that's interesting. Okay. 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or it could be 1, 2, 3, 4, 5, 6, 7, 8, 9 that way. Hmm. Uh, hmm. So that's interesting. If this is the one, that means it has to be light, right? Which makes this 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would mean none of these are light, so this would be gray, 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 gray. This would be a boundary here. This would have to be a boundary here. This could no longer be light. This would be green. These could no longer be pink. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so this would have to be pink. At least one of these two would be pink. Um, this would be at least 4, 5, 6, 7, 8. No, wait, 4, 5, 6, 7 with 2. 24. That seems reasonable. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You'd have 3 other digits remaining. Okay. I mean, that seems... Okay, so this could not be 1 then. So it'd have to be 2 or 3. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We'd have to have 6 more digits possible. So it'd be 1, 2, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 at least. 19, 20, 21, 22, 23, 24, 25, 26. So these would have to not be yellow. They would have to be red. So this would add up to, at minimum, 24. We would have 2 more, and we could have 1 more here. Hmm. And there's one other region that's possible in this area. One would have to be one of these 2 digits. Hmm. That doesn't seem to limit things very much. So if this were a 3, you'd have to have at least... Okay, so let's remove the colors here. This would have to be a separate color. So it'd be, let's say, orange. We could have something like dark go here. And then this would be at least yellow. And then blue would have to go at least that way. I mean, you could have something like this being all dark. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's possible. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, seems feasible. Yeah. Hmm. The only possibility, so this would be all dark. This would be, I guess, sorry, all orange. This would then be 4. 3 could not be here or here. So 3 would have to be one of these two. Which means this could not be 3. If that were the case. Right? 3 would have to be here. And 3 would be taken into account there. This is not a guarantee, though, that this is the way. It could just be like here, right? Then this would be green. This would be light with a 3. One of these could be 1. Would have to be 1, actually. Could not be 1. This is all the same region, so that's fine. Okay. Okay, one thing you cannot have. You cannot have one of these regions equals the same as these 3 regions here. Right? It has to be either 2 and 2. If it's 1 and 3, it can't be 1, 2, 1. It can't be 1, 1, 2 as the region breakdown. It can't be 1, 3 anymore because 1 and 2 are already accounted for. So the minimum of 3 digits would be 3, 4, and 5, which is 12, which is not a single digit. So it's either these two are the same, or these two are the same, or they're all 4 the same. Oh. That means this is at most... So... You could have 2 here the same. These two be the same. These two be the same. This is different. So that would be 1 border, 2 border, 3 border, 4, and 5. So this is 3, 4, or 5 here. Right? So we have a border here. This was light. This was a 2-set region. I guess it could be out to here or something. Or it could just be all this the same region. This is essentially a 2-cell region. So 2, 2. That would be 1 border here, 2, 3 borders, possibly 4, possibly 5. So this is 3, 4, 5 here. It cannot be 7 because you can't have 7 anyways because, yeah, it would be 1, 2, 3, 4, and they would all have to be the same digit, which is not allowed. So that could never have been 6 or 7 anyways. Huh. Hmm. Let's see. Hmm. 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 We don't really have a restriction right now, unfortunately, that I can see. Mm-hmm. Ah, this cannot be dark dark. So this is at least five, I think, right? So if this were dark dark, it would have to be one. These would essentially be the dark area. This single digit would have to add up to three other unique digits and three without one or two, and that's not possible. So I guess these could all be part of yellow though, but it cannot be dark dark. So if it's yellow or something else, some other color, say it's light, I guess this could be dark dark, right? So it could be light light here, border here one, border between pink and green, that's two, border to medium gray. So that'd be two borders here, three here, border between medium and dark, that's four, and then border between dark and orange, that's five. So this is at least five, six, or seven. This can't be light. If this is light, it's a single color, right? Because we already have eight digits already in light. It cannot be two digits here. These, neither of these can be light. These have to be one. So light is either here, here, or here. We're not sure which. This can't be dark because otherwise both of these would have to be dark. And it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this cannot be dark. It's either medium gray or it's yellow. Or it could be blue, some sort of blue thing, right? Some other blue region. So these two are the same region. Um, what else do we have? I'm not really sure. So can this ever be essentially medium? If it's medium, that means all of this is medium, right? Which would fill this. These would not, oops. You would not have medium here. It would have to be dark. Therefore, well, we don't know. All of this could be dark, technically. This would see one, two, 3, 4, 5, 6, 7 boundaries. So this would be 7 here. This would not be 7 here, obviously. This would see how many? 1, 2, 3, at least. 4 between the pink and the green. 5, 6. 6 at least. So this would be at least 6. These two would have to be the same region. So this could not be orange then. It's yellow or dark. 6, 7, 8, 9, 10. It cannot be dark. So it's yellow or it's blue, some sort of blue thing, right? And this is also yellow or blue coming out of here. This would be its separate region, so this would be 4. We have 1, 2, 3, 4. 1, 2, 3, 4 boundaries. The problem is I think this is a 3, so that's why I'm like everything else I'm trying to basically disprove when this is 3. But I can't for some reason. This is 1. These 2 would have to add up to these 2, so there's no 7 here. Okay, how many boundaries? 1, 2, 3, 4 at most, so this can't be 5. This cannot be 7 and 9. These have to be the same region. You cannot 4, 5, 6, 7, 8, and 9, so this can't be red then. This can't be dark because this can't be dark here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's dark cannot be any of these. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or 6, 7, 8, 9. Can this actually ever be pink? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it could be. Wait, we know this is a boundary. This would be this cannot have a boundary here. So that'd be 1 boundary here, 2, 3. So this would be 3 then. It cannot be yellow. It has to be red. This is a boundary here. This is a boundary here. This could not be 3. None of these could be 3. Therefore, 3 has to be one of these 2, which means none of these could be 3. None of these could be 4. Oops. Could be 4. This can't be 4. No 4 here. So 3 is one of these. 7 and 4 would require 5 and 6 here. That's possible. This would have to be red. I guess this could be blue. So this is red or blue. This still could be yellow technically. Well, I'm thinking of taking a break on this one. It's been 2 hours that we've been doing this. And I don't know how much closer we are to solving this. We're looking at essentially possibilities for contradictions here, but we're not finding many. We do know that can't be light there. So this is yellow or heavy or medium gray, or it could be some sort of blue one too, technically. But yeah, maybe we should look at this 3 later on and try to see if that basically caused some contradiction. Because I'm almost certain this is 4. Because this could be 3, which would force that to be 4, and that would be light, right? But anyways, hope to see you next time on as we continue the solving this puzzle. Or maybe some other puzzle later on. We're just going to stop it right now so that we can have a break, refresh our mental later on, and hopefully solve this puzzle. Anyways, I'll see you next time. Take care.